Are you okay?
All right. Anything we say will be held, can and will be held against us.
That's right. Hold on. I think as I did this, my little one just got hurt. Are you okay, Victor? The first recording. Oh.
Why is the color not changing? This is no fun. Like,
I was about to say, do you have white? If I can change this. You okay, buddy?
we have
Okay.
brown and it's not letting us change it.
Okay, I will change it. Hold on. Let's see. Change template. I could do a squared white if we want to. Is that better?
Yeah. Well, we're saying our drawing color is not changing for some reason.
Oh. And then I have to change my color to black. Let's see. This is part of the first class.
Oh, it worked.
Yeah, part of the first class is working out all the bugs.
Yeah. Okay.
Making sure.
We call it. We both agree on. Then
There we go.
blue.
Yeah.
Dark blue.
And then I have to put a mouse.
Oh.
There we go.
Who's making a beat?
Me.
All right, see if everyone
there
can
we
draw
go.
on this for sure. Make sure you can write. Also, make sure you have some sort of a calculator today with you before we start.
Okay.
Okay.
Preferably a scientific calculator, but it doesn't have to be scientific right now if you don't want, but something that can do an
It says scientific.
It says scientific calculator. We're good.
then you're perfect. So again, this is going to be a super casual, it's not really, it's a class, but we want to make it a club, meaning we're going to be discussing things that are on like math competitions and standardized tests. So like the fun stuff. Hey, Em, I can hear myself. Can you go close your door? Okay, it's in the drawer. Okay. Hold on. We have reverb. Practice drawing. So, oh, you guys can hear the reverb, huh? I hear the echo of my voice.
There we go. See?
What's the purpose of that?
I know, I'm racing.
So this will be a fun class. We're basically going to be doing like all of the, if you want an entrance exam into college or a standardized test, and there are those wacky, weird, hard problems that nobody else can figure out, we're basically going to dive into those. Okay, so we're going to go pretty slow and we're going to work as a team. After this club, right, when we're done with all of our different items we're going to go through, you guys would be completely fine to go into like a math competition or something. Okay, so you guys are going to be doing how and why we do some of these weird problems in math and kind of do a deep dive. So ask tons of questions. We're going to go pretty slow, and we're going to, the problems will look difficult, but I think you're going to be really, really proud of yourself once you figured out how to do them. Okay. So so make sure you can write on my whiteboard here. That's number one. If you can't, that's completely fine. Have a piece of paper and you can just shout the answer, right? And make sure you have a scientific calculator, something that we'll do to the power of. And then the next couple times we'll do logarithm. So make sure it does that. Okay, make sure you write on it and then you can erase it. So can everybody also erase? Because I have noticed when I go to the next page, it keeps your drawing on there. So we'll also need to be able to erase everything. Although I think I can also erase everybody. It's gonna be All right, is everyone ready today? All right, so who has the yellow figure? It's super cute, I love it. Awesome, okay. So this will work. So basically, it's a super casual class. This is not your typical math class. Don't ever fear of getting an answer wrong. I love wrong answers because that's how I learn. If I get something wrong, I'll never forget it. But there's really no right or wrong. It's really just working through problems and seriously understanding the math. Okay, so we're going to start off. I'm going to say grade 6, but this is a pretty advanced. But you guys are going to get it, I promise. And if we can't, we're going to work as a team to get it. All right, is everyone ready?
Yep.
Mhm.
All right,
Yep.
integer exponents. What's an integer? Does anybody know?
It's then a whole number.
Right, so not a fraction, right? So we're gonna be talking about whole numbers, negative numbers, and then their exponents, okay? So, and sorry if I get interrupted, I have a 6-year-old that is, in the background. Pay no attention to him. All right, let's start. All right, we're gonna start off with something very simple. All right, so multiplication is simply shorthand for what?
Repeated addition.
Okay.
Yeah.
Repeated addition. How would we write this in multiplication terms? Does anybody know?
Nope.
That's right. Perfect. Everybody knows. That's super easy, right? 2 times 5. That's right. All right. So I won't erase mine. You guys erase yours. All right. So in the same respects, if I put, what does that equal?
3x.
4x.
No. X.
Whatever
4x.
number x is.
Times 4.
Yeah.
Okay. So from now on, thus far, we're at a level of math where when you use multiplication, you don't put any symbol, not even a dot. Okay. So this would just be written 4x. Okay, so if it's side by side, it's multiplication. Also parentheses, you'll see further on, is also going to be multiplication. Okay, so just like we have shorthand for repeated addition, we have a simple way of writing repeated multiplication. Okay, so what is this? What is the shorthand for this? There's a little bit of a lag on my end. Okay, there you go.
Okay.
So what is the shorthand for repeated
Right.
multiplication?
2 square. I think. 2 square 5.
2 to the 5th.
Yeah, power.
So our
Power 5th, yeah.
power. That's right. How many 2s are there?
5.
5.
Yep. So that's how we write.
Hey, mommy. Can I
I'll do-
Yeah, go downstairs. I'll be right with you. Go get him real quick. Hey, can you help your brother real quick? Okay, so all right, so here's our exponents. All right, super easy, right? So in the same respect, what is this? Hey, Em, can you help your brother real quick? Help me out. Emma, I'll go with you, honey. Go ahead.
X to the 4th power.
Very good. Super easy so far, right? All right. So what is 2, when we write 2 to the 5th, what's the 2 called in terms? Does anybody know
Base
what that
number?
is? Yep, very good. Super easy. That's your base. And everybody says that's our exponent,
Yep.
or what we call a power. All right. So how would you actually read? There's 2 ways to read this number. What would you say?
Let's see. It'd be 2 times 5 or 5 times 2, I guess. To read it.
It would
or-
actually be 2 raised to the 5th power, or 2 to the 5th.
Okay.
You can also say 2 to the power of 5. Okay. Okay, now when I say 2 to the 2, what is that called?
2 to the 2nd power.
2 squared.
Yeah, we got a squared. Okay, 2 squared. And if I have 2 to the 3rd power, what is that called?
Cubed.
Cube.
Cube, super easy. All right, now in terms of unit measurement, where do we generally see squared things at? Like,
Find the area of a cube.
there you go. When you start getting into area, you're multiplying length times width, right? And you start to get stuff in squared value. Now, if I have the same thing, but Grace, I think that was you. If you have cubed, what are we talking about as far as units inside of the cube? Where we multiply length, width, and height. We have 3 things we're multiplying. What units do we usually use? That's volume. Oops, sorry, guys. Okay, so that would be volume. This is going to be important to know later on. We're generally going to use things that are cubed, right, in terms of volume, and squared is in terms of area. All right, so let's do an example, everybody. All right, so what is 2 to the 5th times 2 to the 6th? So if it's just repeated multiplication, this is what it would look like. So how many 2's do we have there?
11.
Bingo. So what's our rule with multiplying things with exponents? What are we going to do to these 2?
Add them.
Yes, you're going to add them. All right, so who has a calculator? What is 2 to the 11th?
$2,048.
Does everyone know how to do that? Usually there's like a little arrow button or a power button on your calculator. and it
Yeah.
lets you put the number.
No.
There should be near where you see like
Um,
X.
Can I show you my screen?
Well,
There-
well,
oh,
not.
here.
We'll do it here in a
No,
little
not
bit.
like like share screen, but like show
No.
the camera.
Just pick
Oh,
it
okay.
if you want to.
No, it's not on
Yeah.
those calculators.
It's not on this one.
Lift it up a second.
Lift it up.
Yeah. Okay, I'll have to look at it in a second. You're right, I don't see it right there. Okay, so at any rate, you would put in 2 to the power 11 and get that answer. All right, next example. All right. So when we multiply things with exponents, we add them. here's our next one. 3 to the 15 over 3 to the power of 12. What is that? Anybody have a guess?
You
So if we add the exponents, if we're multiplying, what do you think we're doing when we're dividing?
Canceling.
Which is also called
Subtraction.
bingo. Good job. Okay, so now you see why we have a shorthand, because I've written it all out. We have a shorthand for repeated multiplication. All of those threes are multiplied together. So just like Grace said, we're going to start canceling all of the ones because 3 over 3 equals 1, right? So we're going to cancel all these because they all equal 1. And what are we left with, guys?
3 times 3 times 3.
3 times 3 times 3 all over 1, which is also, if we put it in exponent terms, what?
3 to the cubed.
3 cubed. All right, put that in a calculator. What do we get? Well, actually, you don't need a calculator. What's 3 times 3 times 3?
27.
27. 27.
27. Good job, Ashwin. All right. All right. Let's keep going. I'm going to go something a little, let's change it up. We're also going to do division, but it's going to look like this. How do we do that? What does that mean? All right, so we're subtracting these exponents, right? Or canceling them out. So what will this mean? Technically, this means 1, 2, 3, 4, 5, 6 at the top, and 1, 2, 3, 4, 5, 6, 7, 8 at the bottom. So what will this look like? What is 6 minus 8? We're going to negative region, aren't we? We're going beyond
Negative 2.
That's right. So we'll have, in this term, we'll have 1, 2, 3, 4, 5, 6, 1 over 3 times 3, or 1 over 3 squared, or it will be 3 to the negative 2. Now, hopefully you guys can read that thing. Thank you. All right, I want you to really pay attention to this negative part. Keep going. Because this negative 2 on top is going to be important. When there's a negative exponent, it means you put it in the denominator. Okay, so what is 3 to the negative 2? What is the answer to that problem?
3 divided by 2 or 3 over 2.
Well, so if we take out the negative,
Eternity.
it's 1 over 3 squared, right? So what is 3 squared?
9.
1 over 9. That's the answer. Okay. So 1 over 9. Let's keep going. So if we have, now we're going to turn it to algebra a little bit. If we have x cubed times x to the negative 2, what will that equal? These are multiplied together. So we're going to say 3 plus a negative 2. What does that equal?
X.
That's right. A positive 1, which will just be x. What if I have x cubed over x to the negative 2? Ooh. These are ones that'll be on the standardized test. So
X to
we're
the 5.
subtracting. All right, what is 3 minus a -2 is really what we're doing. And that means
5.
we're adding. That's right. This means we're adding these two negatives change to positives. And we get x to the 5th power. All right. We're going to keep going. Any questions about that? Do we see how we're adding and subtracting exponents? Yes, no, maybe so? 'Cause we're
Yes,
about
I
to start-
understand it.
All right, let's all do some exercises together. What is 3 to the 4th power?
Is
81.
81.
Very good. All right, number 2. Let's do 2 to the 5th times 2 squared.
2 to the
Hey, Emma.
7th.
Emma, can you close your door?
2 to the 7th.
2 to the 7th. What is that?
128.
Bingo.
128.
Okay, let's keep going. We're going to get a little harder. What is 5 to the -3 times 5 to the 5 times 5 to the -1? So all these are multiplying, which means all of these are adding. These little numbers, exponents on top. So we actually have to add -3 plus 5 plus a -1.
5.
5.
We get 5 to the 1 which equals 5. Okay, just, hey Emma, can you get him some more stuff? All right. Please be sure to close your door. It's okay, buddy. Part of having a 6-year-old. All right, bud. All right. Next. Sorry, guys. All right, our next problem. You're coming with me, buddy. 4 to the 3 over 4. Victor. Go with Emma. So if there's no exponent, it's just an understood 1. Now, it is in
16.
the denominator. That's right. It's in the denominator. So it's a -1, really. So it's 4, 3 minus 1 is 2, 4 to the 2 is 16. Good job, Grace. All right, let's get harder. All right, 2 to the 7th over 2 squared. What's that one? So we're subtracting our 7 and our 2. And what do we get? 2 to the
There would just be 2 to the 5th.
Yep. Which is what, guys?
32.
Bingo. 32. All right. Now, let's go a little more difficult. We're going to add some parentheses. 3 to the 4th times 3 to the -2 divided by 3 to the 5th times 3 to the -2. To figure out this problem, you do the numerator first and then the denominator. So they're separate. And then you can solve. So what should we do first, guys? What's the top? What's the numerator? What's 4 plus a -2? Anybody? I know
Um,
you guys know what 4 minus 2 is.
2.
Okay. 3 to the 2 over what's 5 plus a negative 2?
Negative 3. Oh, just 3.
Just 3. You're just subtracting 3 to the third. Okay. So now we're dividing exponent. Now we're dividing two things with exponents. What do we do with those exponents? Do we add or subtract them?
We subtract them.
All right. So what's 2 minus 3?
-1.
-1. So what does that equal?
1/3.
Remember when it's 1 over 3. When it's the negative there, it goes to the denominator, it flips. Okay. Did everybody understand that?
Yes.
Okay. 2 to the 5th, we're going to change it up a little bit. 3 squared times 2 to the -3. So let me tell you, you can only do these exponent rules with the same base number. Only the same bases can add and subtract exponents. So let's do the base 2 first. What is 5 plus a -3?
The answer is 13.
Oh, no. What's 5? You're close though. So 5 plus a -2 just means subtracting, right? So we have 2 squared times, and then it's 3 squared. 3 does not change because it is a completely different base. So what's 2 squared, guys?
4.
Four.
That would be 4.
And then what's 3 squared?
9.
9.
So what's your answer?
36.
There you go. You got it right. All right. So the key to that problem was you can only add and subtract the exponents with the same base number. Okay. So let's continue with different base numbers and what we can do with them. All right. So let's use a base 5 squared, a base 3 to the -1, a base 2 to the 4th, base 5 to the -1, base 2 to the -2. All right, so let's do the exponent rules with similar bases. All right, so let's start off with 2 first. What does this equal?
Yeah.
What is 4 plus a -2?
2.
Okay. Then we have our 3 here, right? Because there's no other 3. So 3 to the -1. And then we have 2 5s. So what do our base 5s add up to there in exponents? We have a 2 plus a -1.
1.
1.
Numero uno, that's right. All right, so this equals 5. And then what is this? 2 squared.
A 4.
5 times 4. Now, who remembers if you have a negative exponent, what that means?
It's a fraction.
It goes underneath. That 3 goes right underneath. All right, so who can solve this problem? What do we get? It's an improper fraction, I'll tell you that.
20 over 3.
That's right, 20 over 3.
Mm.
Okay, so these were just exercises on making sure you understand adding and subtracting negative and positive exponents. And also how you can only do that with the same base, right? Now, what if you had something like, so some like math exams and stuff will try to trick you and do 3 to the third over 3 to the third. So what does that equal? And what's 3? 3 minus 3.
0.
0.
0. Okay, so here's the trick. Anything with the power of 0 is going to equal 1.
That was
how
my
we solve
speaker.
it. All right. Now we're going to get even more difficult. All right. What if I give you 2 cubed to the power of 5? Okay,
15th power.
close. So
Don't
if
Don't you
have
multiply
two
it?
things that are, if we have 2 things that are multiplying, 2 bases that are multiplying, we add the exponents. But now we have 2 exponents. We have an exponent to an exponent. We're actually going to multiply these.
It's 15.
That's right. We get 2, no. Oh, sorry. Yes, 2 to the 15. Sorry.
That's what Grace said, and you said no.
That is, you're right. I am so sorry, Grace. You were absolutely correct. I was looking at something else. Okay, so you get 2 to the 15. That's right. And then you solve from there. All right, so here's the next one. 3 to the power of 5 squared. What's that?
3 to the 25th.
No, what's 2 times 5?
10.
3 to the 10th. All right, and if we do 4 to the negative 3 to the negative 2, do you guys remember the rules about multiplying 2 negatives?
Equal a positive, so 4 to the 6th.
That's right, 4 to the 6th. Does everybody see that?
Yes. Yes.
Okay. So I'm gonna do, all right. So the next thing that we're going to do when we're doing multiplying exponents is something that's going to look like, it's gonna look like this. Here, I'm gonna start a new page real quick. If I gave you 25 to the half power. All right, now everybody knows what this is actually. It's just hardly written this way. Does anybody have a guess on what this could be? If something is raised by a fractional exponent. Any guesses? I love wrong answers.
Try again.
12.5.
Okay. So what is that? Half?
5.
The answer is 5, but how did you get there? What did you do?
A half of 25 is 5. 25 to the half.
So what you're gonna do is that. Does everybody know what that is?
Square root.
It's a square root. That half, a fractional exponent, means square root. All right, that's its special name. Okay, what's this sign called here?
The radical.
Called a radical. And we'll learn later on, inside is going to be called a radicand, okay? But right now we're just going to deal with a radical. And so we write this 20, the square root of 25. Now, does everyone know what square roots are?
It's when like you have something, or when you figure out what number times itself equals the number that's under the radical.
Right, so we're gonna ask ourselves, what number multiplied by itself 2 times equals the number underneath the radical sign? So what number multiplied by itself equals 25?
5.
5 times 5 is 25. So when we see something written, like if you are on a standardized test, they'll trick you and say 25 to the half power. That's just the square root of 25. Okay, so what's the square root of 81?
9.
Number 9. That's right. 9 times 9 is 81. All right. Now I'm going to show you something that is definitely on standardized tests because they are trying to confuse you. All right. So they're wanting to know, all right, 2 integers, which are whole numbers, right? That are between the square root of 55. All right. So let's talk about some of our squared numbers. What's 5 times 5?
25.
25,
What's 6 times 6?
36.
36,
7 times 7?
49.
49,
8 times 8?
64.
64.
Okay. So this here is between 55 is between 49 and 64. So the 2 integers that have square roots between the square root of 55 would be 7 and 8. I like this one because it practices your, multiplication double. It kind of reignites that if you're used to using a calculator again, and you forgot your times tables there. All right, let's go a step further. What if I had, what if I had 8 to the 7th? What if I had a fraction, but it wasn't half, it has a 7? The way we would write this is square root, so the radical sign, and you put this little 7 right here in this little spot here. Okay, and then you put the base number as usual under the radical sign. Okay, that's how that would work. You see this a lot in science. So if I said 10 to the 5th is what? 10 with some zeros behind it, right? How many zeros?
Oh,
5.
that's right.
Okay, so this would be, so if I was to change it and go like this.
You can do the same thing.
So it can go backwards and forwards. 10,000 to the 5th would equal 10 because that's the square root of, 100,000, my bad, would then equal 10 because 10 to the 5th is 100,000. So we kind of go back and forth. All right. So you won't see 1 over 7 quite a lot. You'll see the cubed root of something. I don't know if anybody's ever shown you that before, but so obviously the cubed of something is 3. So a cubed root would have the radical with a 3 in it. Okay, that would be called a cube root. All right, so let's do an example of a cubed root with a little twist to it. All right, so on a test, they might give you something like base 8 2 to the power of 2/3. Okay. It might look like this. Now, the only way to do a root of something is the numerator has to be a 1 over a number. Okay, like 1 over 2 is the square root. Okay, 1 over 3 is a cubed root. So this has a 2 in the numerator. So in order to remedy this, we take our base 8 and we say 1 over 3 times 2. So we piece it out because we know from the last time the last little section, when we take a square of a square, you multiply these things. So you can piece it out. So 1 over 3 times 2 is 2 over 3. All right. So let's do this. All right. What's the cubed root of 8, everyone? What's one number multiplied by itself 3 times would equal 8?
Two.
512.
So this would be
Two.
the cubed root of 8. The cubed root of 8 would be 2. Can everybody see that? Do you want me to go over that? Meaning 2 times 2 times 2 would equal 8. So I'd place a 2 as the answer, and we still have the squared.
1/3 of this is a 2. 2/3 of this is that.
And so 2 squared is then what?
4.
All right.
Oh. Yeah.
I'll
And Miss
stop.
Tara,
Yes.
what would in the cube? What would the cube root of 3 be?
Right.
Oh, okay. So that'll be our next. You can't, right?
Mhm. Just like you
Okay,
can't
so-
square root 2.
Yeah, so that'll be our next question. You actually have to piece it out in the base. It's going to look like what 2 things multiplied together equals 3.
Yeah, technically it should be 1, but you can't multiply 1 by 1 and get 2.
Right. So we will go over that next. We're going to do these nice, pretty numbers first that equal a whole integer. But we will go over that because they have that on many math competitions and tests for sure. So here's what a cubed root is. All right. So let's practice. So I know people are kind of unfamiliar. Let's practice piecing out fractional exponents. Okay. So let's try another one. All right. We're gonna do 8. Hello, Mr. Green. All right, we're gonna do 8 to the 5 over 3. So how would we write that? I want you guys to actually do it on the paper here, on the screen. So we want it in something that has an 8 to the 1 over. You guys can draw on this page all you want. I mean, math problems. If you can. So we're going to break this 5 over 3 apart. This would be 8 cube root, right? Because we like cube roots. Because we know what 8 cube root is, right? So we got that one. And then we just parentheses 5. Very good. Awesome, guys. All right. So what is the cube root of 8? We said it last time. What is it?
2.
2 to the 5th. So what's that answer?
25.
Think again.
10.
No, it's not 2 times 5. It's 2 times 2. Remember, this is repeated multiplication. 2 times 2 times 2 times 2. 5 times. So what's 2 to the 5th? 32. Thanks, guys. All right, our next problem. All right, now we're going to go back to our radical sign. I'm going to say the square root of 8. And inside our base is going to be 2 to the 3rd. We're getting exponentially more difficult. All right, so what does this radical sign mean in fraction form? Who remembers what it means? What's the other way to
Square
write
root.
this? Right, but how do we do it in the exponents? Like if I would say 8 to the what?
Oh, 1/3 parentheses to the power
Well,
of
this
2.
is just a regular square root, so it'd be 1/3.
3.
Nope, that's a cubed root. A square root is the 2. That's right. All right, so we have 1/2 to the 2/3. All right, now we're just multiplying fractions. Remember that time in class when you're doing fractions and you're asking your mom, why do I have to know how to multiply fractions? So what is the answer to this? What do you do when you multiply fractions? I think you can cross some stuff out, right?
You add them.
No, we're multiplying fractions. So we can cross out these 2's and we get what for our answer? Ah, somebody wrote it. Very good. 8/3. 8 to the 1/3. The cube root of 8, right? What's the cube root of 8, everyone?
2.
That's right. 2 times 2 times 2. Okay, let me know if you want me to slow down. Okay, let's go a little harder. What does this mean, everybody? What does that mean?
The 4th cube.
The 4th root.
4th root.
Okay, the 4th root of 81 to the -3. All right, we're going to take this radical sign out. Okay, I don't like the radical sign. I like working in fractional things. Okay, so if I was to take this radical sign out, this would equal 1/4. Okay, the exponent 1/4. So I'm going to actually multiply it to what I have here. I have 81 to the -3/4. Does everybody see how I did that?
Yes.
Okay. So now this is a little easier. Now I can say 8 to the 1/4 to the -3. Piece it out again. All right, so what's the answer to, oh, sorry, I'm forgetting a number. Oh, 1, that's 81. Okay, so what number multiplied 4 times would equal 81? So what would that be? Three. Very good. Who is red? Because you're doing excellent. Is that you, Levi?
No, it's not me.
Grace. Okay, whoever's doing that is excellent. All right, so this would equal 3 to the -3. What's that negative mean? It means it's going to be over a
Fraction.
denominator. I mean, over a It
Oh,
is
under.
Thank you. It means that. So what is 3 to the third?
27.
1 over 27 would be the answer. Okay. We're gonna get a little more difficult. What if the base was also a fraction? So how we would do this one is we'd kind of distribute. So we put this numerator, this exponent on this one and this exponent on this one. So we'd say 1 to the 2/3. Now I love this number. Why do you think I love 1 to the power of 2/3? What is 1 to the power of 5 million? 5 million.
Because it just equals 1.
Yeah, you're just multiplying it to itself that many times, and 1 times itself is 1. So 1 to the 2/3 doesn't really matter. Anything to the power of 1 is going to be 1. Okay, so the only number I care about really is 8 to the 2/3. Okay, so we go, okay, cool. This is going to equal 1. This right here, we can piece out, right? To 8, the cubed root of 8 times 2. And we already said the cubed root of 8 is what, guys?
2.
2 squared. So this would equal 1 over what?
2.
Nope, 2 squared.
4.
Yeah, there we go. All right, do you see how we got there? Very good, guys. All right. All right, one last problem. What time is it? Yep, one last problem, and this is going to be pretty difficult. This problem would probably be on a college entrance exam, and you guys are going to do it. Okay, you ready? Alexis, I see you going, what? All right, here we go. I want everyone to attempt this. 4 to the 2/3, 2 to the 1/6 times 3 to the 3 over 2, all over 2 to the negative half. Sure, just 1 second. And times 3 to the half. All right. And I'm going to let y'all figure that out. You can write on here all you want. Well, I plug this in. This way, bud. All right. Any takers?
Wow.
Yeah. So
Oh, I remember this question.
yeah, that 4 is
remember
going to
that
be an
question
issue.
too.
Yeah, that 4 is going to be an issue. We've got to change that 4. And that is going to be the trick to this whole thing. This is one of those questions that they put on a test and they just want to trick people. All right, so what is another way using an exponent notation to write 4? Like what 2 numbers multiplied together would equal 4?
2.
A 2.
So another way you can write 4 is going to be 2 squared.
Grace already figured it out.
You have figured it out, Grace. Great job. I'm highly impressed, Smarty Pants. All right, so if we do 2 squared as 4, and we have plus another 2/3, because we have a 2 on top here. So this is going to equal 2 to the 4/3. I'm going to go back to black. All right, so another way to write 4 to the 2/3 is 2 to the 4/3. You're just going to add another squared on there because your base is changing to 2.
Yes.
Okay.
4 to the 1/3 to 2.
All right, now we have bases 2 and bases 3. All right. So it should look something like this. Two to the -1/2 times 3 to the half. Oh, yes. All right, does everybody have that? That was the trick of this whole thing, because now so we have some bases that are same, and we know if we multiply, we're going to add the exponents, and if we divide, we're going to subtract some exponents. So let's do the base 2's.
Y2,
All right, so we have 2,
Y2.
and we have 4/3 plus 1/6
It's negative 1/2.
Oh.
minus
And cross
a
the.
negative half.
Oh, never mind, they're negative.
That's right. So a negative minus something flips those signs to positive, right? All right, so we're
Yes.
adding fractions. We're adding these fractions. Who remembers how to add fractions?
Find the common denominator first,
Of
which is 6,
course.
which is 6.
That's right. So 4/3 plus 1/6 plus 1/2 is all 6. All right, so what's my top number here? We multiplied by 2. Right. And what do we get right here? Does everyone want to fill it in for me? What does 4/3 turn into if I make the denominator 6?
So that would be 4 times 4 times 4.
No, this is just this is a normal
Oh.
fraction, so it's 12. So we put 12.
Mm-hmm. That's right, 12. Very good. All right, so what we're going to end up
Uh,
with,
It's not this, it's just the normal fraction.
15/6.
thank you guys. Good job filling stuff in.
11/6.
All right, so we have 8 plus 1 plus 3. And we get what?
12/6,
12/6,
which is 2.
which is 2. All right, so all of these fractions here added up to
2.
2. So this is really simple, right? So we have 2/2. Or sorry, 2 squared. All right, now let's do the 3's. So we're going to subtract those 2. So what is 3/2 minus 1/2?
2/2.
Oh, you're so easy. What's 2/2?
1.
1. So this is just 3. So we have, well, I'm going to write that out so everyone can see it. With our base 3's, we have 3/2 minus 1/2. Okay. And then that just equaled 2/2, which equals 3 to the 1. Okay, so what's the answer? I know Grace already put it down.
3.
What No, 2 squared times 3.
Oh,
It's 4 times 3.
Which is,
Well,
12.
bingo. Good job, guys. And I love all of your drawings.
Do you see the entire woman we drew on the side of the screen?
Uh-huh. Okay, so that is our lesson for today. That was, I just want to show you guys before class, if somebody gave you this problem right here and said, hey, I want you to solve this, you would go, what? Although some of y'all could probably do it. But knowing that fractional things really just mean square roots or some root of what it is. That negative means kind of taking the reciprocal of something. So what I'm going to do is I'm going to give you guys about 6 practice problems to do at home. And then the next time we're going to go over them and you can kind of check your work on them. Okay. So I will send those out on the Facebook page. I'll just send a little link to it. You guys can print them out. I think it's like six problems or so. And they're all going to be just like this. So nothing new, but what we've worked here. All right. Any questions about, I still have all these written down. So if you want me to go back to something to kind of go over it again, let me know. Is there any problem that you had confusion on?
Not for me.
I have a question.
Yeah.
What are we gonna work on next?
Our next is going to be what Levi kind of touched on, is what if when you do a square root, it's not a whole number. So let's say the square root of 8, right? We'll do is really 4 times 2. So we're going to figure out how to put a number, a whole integer on the outside in front of the radical instead of inside the radical. Okay, so we're kind of going to do it that way, but it's the same type of thing. We're going to still go over our exponents and our square roots again. So we get really good on those.
Okay.
And you'll
Yay.
see some crazy problems. All right, so what do you think? So basically these problems that you did today are gonna be, here, so any other, before I leave this and get out of it, any other one you guys want me to go through? Okay, well, you can always kind of message me if you have another question. All right, so what we did today, all those problems would be either on like a math competition or some sort of standardized test. You know, when you do I don't know how many standardized tests you've done, but usually they start off easy and then they get really, really confusing and hard near the end. These would be those confusing, hard problems that nobody can figure out. Okay. So when you go to take a college test or an entrance into some sort of grade test, these would be the difficult questions that they would give you to see how much you know about exponents. And
We're just
So those are
smarter.
the exact questions, so I can just get all the answers to them.
yeah. Yeah, some of them are actually.
It would be so awesome. It would
Yeah.
be so cool.
Yeah, I try to pull from, if I remember, even in my science class, a lot of stuff will be, hey, I remember a question like that on a college entrance exam. So like an ACT or an SAT, and I try to put it in there for you guys. So you won't be bombarded when you get to that. Okay, any questions about Math Club? So this is totally different than your normal math class. That's more like problem after problem of the same thing. This is going to be 1 or 2 problems.
Nah, bro, she froze.
Emma,
Hi,
Emma.
Miss Tara.
can you tell your
She,
mom she's frozen?
You froze.
I screamed to your mom that she froze.
Yeah.
Mom, you
You're muted, Mom.
froze.
She's just stuck like that.
Does
Yep,
she
she
hear
did.
us? I
Come
mean,
here.
does she hear us though?
I'm pretty sure she
She's
can.
connecting right now.
Can you hear
Oh.
me?
You know, this is still recording.
Can you hear
class.
me?
Oh, somebody else is
Can
host
you
now.
hear the
Who's
silence?
hosting?
Cordelia.
Who's
See the
Cordelia?
noise?
Cordelia.
That's Grace.
Oh, okay,
So
okay, okay.
Great. Taffy
broken.
Love's
Okay,
host
okay.
now.
Feel my heart. I have no idea how that's gonna work with the recording, but I completely lost internet.
Yeah, uh-huh.
It says you're still recording.
Yeah, we're still recording.
Okay, cool. Yeah, my internet goes out sometimes. Okay, so any other questions, guys? That was our math class for today.
So you'll share the link so we can rewatch this.
Oh, yeah. Hopefully now that I randomly got kicked out, hopefully it didn't disturb anything, but if you want to rewatch it and redo some problems and write them down and kind of pause it, you can do that.
Awesome.
And then next time we'll just kind of build on that. And with the I don't know if we'll call it homework, but the exercise problems that I'm going to give you, we'll go over that next time as well.
We'll call that homework.
These problems will be really cool because everyone will be struggling in their, test to get into, 7th grade, 8th grade, 9th grade and college. And you'll be like, that's easy. I know the cube root of 8.
2, and we will never escape the cube root of 8.
That's right. All right, you guys good? Any other questions? I will stop recording. Let's see.